Hello. It's Tuesday, January 6th, 2026. Welcome back to my little corner of the internet. Today, I'm digging into a really fascinating article from the archives that's making waves again. I hope you're ready for some science talk. Because honestly, talking to myself about algorithms is my idea of a party. The title is Adapting Natural Language Processing Models Across Jurisdictions, a pilot study in Canadian cancer registries. The crawl is Tatsid. Arts. Open 967.787 line. Okay, let's break this down. This paper tackles a really serious and important problem. How we track cancer data. You see, keeping track of cancer cases is crucial for research and policy. But the way it's done, well, it's a bit old school. Traditionally dribbled manually, which are basically the doctor's notes describing a tumor, to decide if it's cancer, and if it needs to be recorded in the official registry. This manual process is incredibly slow and expensive, sometimes leading to delays of up to 2 years before the data is actually available, which is obviously not great when you're trying to fight a disease that moves fast. So this paper explores using AI, specifically natural language processing, to automate reading these reports. But with a twist, they wanted to see if a model built in one place, could work in a totally different place, Newfoundland Labrador. It's like if I meant to cook lasagna in Italy. Can I still make a good lasagna in my tiny apartment kitchen with different ingredients? The answer, according to this paper, is yes, especially if you tweak the recipe a little bit. This technology isn't just for medical records, but has huge applications in our daily lives. One application is information extraction. Imagine you have thousands of receipts from different stores. This tech can automatically pull out the total amount, the date, and the store name, even if every receipt looks completely different. It's a lifesaver for anyone who hates doing expense reports. Another big one is in chatbots and virtual assistants. You know when you call customer service and talk to a robot? These systems use similar underlying technology to understand what you're asking, regardless of your accent or the specific words you use. So they can actually help you instead of just annoying you. And of course, machine translation. Translating languages is hard because context matters. Just like the cancer models need to understand medical context across different provinces. Translation apps need to understand that cool can mean temperature or popularity, depending on what we're talking about. Well, let's dive into the nitty-gritty of the paper. The researchers took two powerful AI models called Dynmatron and Gigatron, which sounds like the name of a robot dinosaur movie, doesn't it? Anyway, they found 10 these models on data from Newfoundland Labrador. They are looking for two things. Tier 1, is this report talking about cancer or not? And Tier 2, if it is cancer, is it the kind that the registry actually needs to track? They used a clever technique called an ensemble, which basically means they made the models work together as a team. One model focused on the exactly style data, and the other focused on the fruit doctor's notes. By combining them with inner logic, meaning if either model said, hey, this looks like cancer, they flagged it, they managed to catch almost everything. They achieved a 99% on-call rate. That means they barely missed any cancer cases, reducing the number of misreportable cancers from over 50 using single models down to just 33. That's a huge improvement when we're dealing with people's health. The coolest part is how they handle privacy. Health data is super sensitive, obviously. You can't just email patient records across the country. 7. So instead of sharing the patient data, they just shared the weights of the AI model. Think of it like sharing the recipe for the lasagna, but not sending the actual lasagna itself through the mail. The data stayed safe in each province, but the AI got smarter. This is a big deal because it proves that smaller provinces or hospitals, which might not have the resources to build a giant AI from scratch. It saves money, it saves time, ultimately. It means we get better cancer data faster, which helps researchers find cures and helps governments plan better healthcare. It reminds me of that time I tried to build a bookshelf without instructions. It did go well. And if I had just used the instructions from a friend who built a similar one, I probably wouldn't have books all over the floor right now. Oh wait, nobody understands my D jokes. Anyway, that's the gist of it. It's a really promising step forward for healthcare technology in Canada. Thanks for listening to me ramble. See you next time.